Hello everybody. In this clip I want to discuss with you the concept of concentration, because this is such a fundamental concept in anything biology and chemistry, and yet it sometimes causes people quite a little bit of problems. And well, we are all familiar with the concept of concentration. So, for example, here you see the picture of some juice or whatever it is from a diluted form to a rather concentrated form. And that gives us a clue to how we can define concentration. Concentration is simply defined as the amount of a substance, in a given volume. That is the basic definition of a concentration. And these things can, of course, come in different flavors, not just in terms of the juice here. While the volume usually is not very ambiguous, it is usually, in our case in biology, it's usually liter or smaller units of that, let's say milliliter or microliter. Not very often we have the larger unit of a kiloliter, which would mean 1,000 liter, which is also written as meter cubed. And that's usually fairly standard, but the amount of a substance that can come in different flavors. One of these concentration definitions that we will come across very frequently is the number of entities per volume. So, for example, we might have 6.022 times 10 to the power of 23 molecules of a substance. In exactly the volume of 1 liter. So here we have the number of entities and the volume, and that is a perfectly valid concentration. We can leave it either like that, or we can make life much easier for ourselves, because we know that we can write this as 6.022 times 10 to the 23 molecules. We can write this as 1 mole per liter. 1 liter, given that we know that 6.022 times 10 to the 23 entities equates to 1 mole. That is the definition of a mole. And this usually is also abbreviated, because biochemists, bioscientists are lazy people. So 1 mole per 1 liter is commonly abbreviated as just simply 1 molar, where we write this mole per liter with a capital M. Please write it with a capital M, not with a lowercase m, because that would mean meter. So this just simply means a molar solution. And of course, very often we will come across as smaller units, so we might come across as 1 millimole per liter, which we could write as 1 times 10 to the minus 3 mole per liter, or 1 times 10 to the minus 3 molar, or we can also write this as 1 millimolar. So these are all different variations of how we can write when we are talking about the number of entities per volume. And that's a very, very interesting concept, and I really need you to understand that. Another way of expressing a concentration is if we don't want to go down the route of entities per volume, we can express this as the mass of a substance per volume. So we would usually express that, for example, as gram in 1 liter or milligram in 1 liter. And of course we can think of different variations. So we can, for example, express 1 milligram in 1 milliliter. We can have that. And this, of course, can be written as 1 times 10 to the negative 3 gram. That's our milli in 1 times 10 to the minus 3 liters. That's the milliliter. And what we see is that the 10 to the minus 3 cancel out. So 1 milligram per milliliter would be equivalent, and I write it like that, to 1 gram per liter. So that's when we use the mass in a given volume. And again, that is a perfectly valid concentration. Sometimes you will also see it expressed in a slightly different format when we're usually working with aqueous solution in some substance in water. We might express the concentration as percentage, and this means that we have a amount of grams. So we have a mass in 100 milliliter of volume of water. 100 milliliter water. We know that 100 milliliter of water have exactly a mass of 100 grams. So 100 grams is equivalent to 100 milliliter of water. So what we can do now is we can say if we've got 1 gram of substance in 100 gram of water, which is equivalent to 100 milliliter, then we can write this as 1 in 100, 1 per 100, and this can be expressed as a percentage, so this would be 1%, but we need to indicate that we are talking about a mass per volume, so therefore we use the abbreviation WV. This indicates that we have 1 gram per 100, let me write this down, 1 gram per 100 milliliter of water. A 1% weight per volume solution is equivalent to 1 gram per 100 milliliter of water. Sometimes we also come across another definition, or not a definition, an extension of what we just discussed, of the percentage, which is expressed as ppm and ppb. ppm stands for parts per million, and ppb stands for parts per billion. And when we said previously that percentage weight per volume actually means parts per 100, that's the percentage, then we immediately find out what this ppm stands. So that's just simply an extension of that part per million. So we would get 1 ppm would be defined as 1 milligram of a substance per 1 liter of water. And we note that 1 liter would be equivalent in mass to exactly 1 kilogram, which is 1,000 gram. So this would be 1 times 10 to the 3 gram. So 1 ppm is 1 times 10 to the negative 3 gram divided by 1 times 10 to the 3 grams. And when we use the laws of exponents, so we would get 1 times 10 to the negative 3 times 1 times 10 to the negative 3 would be 1 times 10 to the negative 6. So that's our parts per million. And we can convert that very easily, ppm, into a milligram per liter concentration. And likewise, 1 ppb would be 1 microgram in 1 liter. So this is another form how we can express concentration.